Hello everyone, my name is Shay Topol with the Alliance of Crop, Soil, and Environmental Science Societies, and this is Down to Earth Science. Today, we'll be talking about how well soil holds water and the impact that has on our food supply. Since farming was first invented, people have known that crops need a strong water supply to grow, and that they will continue to grow based on how well the soil holds water. When soil does a good job of holding water, it helps farmers use water more efficiently and survive drought. To understand how well soil holds water, you need to answer two questions. One, what is the soil's capacity for holding and storing water? And two, are all soils the same in this capacity, or do they behave differently? When water from rainfall or irrigation touches the soil, part of it gets lost in runoff and evaporation. The remaining water enters the soil and thus becomes soil water. Soil itself is a mixture of mineral particles, organic matter, and pore space. Smaller pores hold water tighter than larger ones, while larger ones help the water move downward and replenish the local groundwater supply. There are three kinds of soil water: excess water or gravitational water, available water, and unavailable water. Water moves through soil with what is called capillary force. When all of the soil pores are filled, the soil becomes water saturated, reaching its maximum capacity to hold water. This only lasts for a short period of time, and gravity usually causes the rest of the water in the large pores to drain out. Once the large pores are drained, the medium and fine pores will still have some water. This is because of capillary force. Capillary force is what pulls water upwards through the soil pores. Because the smaller pores have less diameter than the big ones, they hold more water and can push back when gravity would otherwise make the water go down. When water drains out of the large pores, plants can still absorb water out of the small pores, but it takes them more energy. When soils get drier, it becomes harder and harder for the plant to take up water because it needs to use more energy just to get it. This then reduces the energy the plant has for growing and flowering, which causes wilt. They can even reach a permanent wilting point if there's not enough water in the soil for them to use. And when plants have to use too much energy to absorb water, they become water stressed and may never recover if it goes on for too long. Soil water content at this point is called permanent wilting point. There can still be water in the soil at this point, but it won't be available for most plants. A soil's texture and structure determines how well it can hold water. Texture is determined by how much sand, silt, and clay is in the soil, while structure is determined by the size distribution of and space between soil pores. For example, coarse soils don't retain much water because their pores are larger, while medium and fine textured soils have many small pores and can hold a lot of water. Unfortunately, the soil's capacity to hold water still doesn't tell us how much of that water is available to plants. Fine textured soils, for example, hold most of their water in tiny pores that don't lend much to the plants. Medium textured soils have more medium pores that can hold water without losing it, and that aren't too hard to extract to the plants. One way to ensure that soils have more water available to plants is to increase their porosity. Soil compaction is also a common problem where large and medium pores get crushed into smaller pores that make water less available for plants. For this reason, farmers try to avoid field management when the soil is wet because then it gets compacted. While you can't change soil texture, you can improve its structure by adding compost or fertilizer to promote pore development and thus increase water holding capacity. This ensures that plants have enough water to grow big, healthy, and strong. Thank you all for listening in today. My name is Shay Topol with the Alliance of Crop, Soil, and Environmental Science Societies, and don't forget to like and subscribe if you enjoyed.